Stefan while Alexandros pull the pitch. So thank you for your presentation, very much on the point. So Alexandro, the stage is yours. Can you also please introduce yourself shortly?
Yes, thank you. My name is Alexandros Proustekis, and I am a senior researcher in ICCS, which is the partner of the Koala project in charge of the so-called prescriptive quality analytics. For the next 10 minutes, I'm going to explain the approach that we have adopted in Koala about analytics related to the manufacturing quality. So the background for this work is this analytics value escalator, in the sense that prescriptive quality analytics aims at addressing the full data analytics life cycle. So according to this analytics value escalator, we covered descriptive analytics, which answer questions about what happened, diagnostic analytics about the reasons why something happened, predictive analytics, which is related to what will happen, and prescriptive analytics in order to recommend the best actions that can address the problem at hand. One of the novelties here is that this data analytics life cycle is coupled to the augmented analytics concept in two ways. From a user perspective, it facilitates the interaction between the user and the AI algorithms and systems through the digital intelligent assistant that Stefan has already presented. And on the other hand, from the technological perspective, the procedure of configuring and of selecting machine learning models is automated, as I'm going to explain a bit more in the subsequent slides. So prescriptive quality analytics in the context of the Koala solution adopts or embeds four main functionalities. That is, first, exploratory analytics in order to provide statistics for the quality of the production, either as a whole or for its individual components, so information about products, defects, etc. The second functionality has to do with the risk assessment in order to evaluate the defects criticality with respect to the products and other parts that may be affected. The third functionality has to do with predictive quality in order to provide predictions about defects. Of course, this is something that is provided upon user request, so multiple analysis can be supported here. And fourth, quality recommendations about actions in quality control in order to optimize the whole quality control procedure. Apart from the outcomes that are exposed to the user by voice, that is through the digital intelligent assistant, these outcomes are also communicated to the user through a dashboard. And this happens because there are much more information that can be derived from the available data after applying the data analytics algorithms that can be also useful for the user. So as an overview, prescriptive quality analytics enables the development of several independent analytics processes with different scopes, that, as I said, addressing issues related to descriptive, predictive, or prescriptive analytics, and by combining multiple data sources. So for the four aforementioned functionalities, there are various algorithms that are implemented and that can support these functionalities and the needs or the requirements by the users related to the analytics outcomes. And as I said, these outcomes are communicated by voice, but also they also provide visualization through a dashboard for issues or for information that cannot be communicated by voice. Another novelty in this context is, as I said, one thing is how to couple the whole data analytics life cycle with augmented analytics from a user perspective. From the technical perspective, there is also a novelty here in the sense that the component adopts an automated machine learning approach in order to simplify and automate the whole machine learning pipeline. So in this way, it reduces the time-consuming task of constructing a machine learning model for quality procedures, while it minimizes human intervention during the configuration of machine learning models. In other words, the AutoML technology that has been embedded selects the best machine learning model if this is something that can be done according to the available data and to the user requirements. But in general, it selects the best machine learning model that fits to the available data and to the problem at hand. In this way, it is able to define better and efficient machine learning models. So just as an example, in a scenario, in the Whirlpool case, we have combined AutoKeras and Fedot technologies from the AutoML library of Python, and upon a GraphQL API about, for example, a new defect, a prediction about a new defect for the upcoming days, this is embedded to the respective dialogue in the digital intelligence assistant. Of course, more practical examples and how these are instantiated in the Whirlpool business case, but also in the context of specific dialogues through the digital assistant, this will be covered by the next two presentations. Finally, let me say a few things about the technical architecture that we have implemented. I'm not going through the technical architecture in details, but this is mainly to mention that the way that the architecture has been designed and implemented makes feasible to implement various analytic scenarios while it supports dynamic deployment. Of course, as I said, it is able to employ several machine learning algorithms and AutoML techniques. It is easily extensible since it provides the basis for embedding additional algorithms, while it also has a filtering mechanism to support various visualizations and to provide different views of the generated insight when we are talking about the dashboard. Of course, there are also additional actions, or there are additional capabilities that have to do on how to filter or to select the way that the analytics results will be communicated to the user by voice, because how to communicate these results through a dashboard and through a digital intelligence assistant, these are two different things in terms of the way that we treat the analytics results. Thank you for your attention. And now I'm giving the floor to Enrica Bozzani from Whirlpool.